Welcome to the Potential and Kinetic Energy Ski Jump Virtual Lab. Ski jumping is a thrilling and dangerous sport. An elevator does work to lift the ski jumper away from the surface of the earth. Due to the mutual gravitational attraction of the ski jumper and the earth, potential energy is stored in the system. This gravitational potential energy is released as the ski jumper races down the track. A small amount of this energy is dissipated as heat due to friction and air resistance. The ski jumper has enormous kinetic energy that he must dissipate safely to avoid injury. All of the initial gravitational potential energy can be carefully accounted for. You will be investigating a variety of scenarios to determine the best combinations for achieving the best jump. Let's take a look. The first variable is the jumper mass, ranges from low to medium to high. The next variable is the jumper's form, ranges from poor to fair to good to excellent. And the last variable is the starting height, ranges from 100 meters to 120, then to 140, 160 meters, and the last is 180 meters. Up here in the upper left, you see the flight distance graph, and what you'll see here is the actual flight distance with each scenario and the path that the flight takes. When it's all said and done, you will also see the flight distance up here, which is what you will record on your data sheet. Over here on the right hand side, this is where you will see the potential energy, the kinetic energy, the heat or thermal energy that dissipates as the flight takes place, and then you'll see total percentages over here. So let's look at a scenario here just to show you what you'll be looking at. I'm going to set the jumper mass to low. I'm going to set the form to excellent, and I'm going to set the starting height to the very lowest of 100 meters. All right, so as you can see, when I change, you can see the graph up here, the energy graph changes. So when I set it to 100 meters, we can see that the total energy is going to be probably about 45. If you notice here, it says 30 to 60, so about halfway is about 45, which we're real close to that. So let's see how this jump plays out. So you can see how the graph, the energy graph is changing. And now that the jump is complete, over here you can see your flight distance of 83 meters, and you can kind of see how that flight path took place, which could be very important in some of the analysis questions at the end of your lab report. Over here, what you see is the breakdown of the total energy. The dark is the heat that was dissipated, and the remaining green is the kinetic energy. You will be calculating proportions based on that too, so this is a very important graph as well. I think we can all assume that a jumper with a low mass will not be the optimal combination for having the longest jump, and obviously a jumper's form plays a part in that as well. So we're going to assume with every scenario that the jumper's form is going to be excellent. I think we can also assume that the lowest starting height of 100 meters will also not be optimal. So we will start with 120 meters, and we will use medium and high jumper mass. Before continuing on, make sure that you have completed the hypothesis on your lab report. When you're ready, continue with the video. There are 8 videos for each of the scenarios on your lab report. If you have all the data that you need, I guess it's time to jump into the lab report. Good luck.